we are going to explore how consumer purchases of digital cameras are seasonal and how we can understand that seasonality with a clear visual approach. Consumer purchases of digital cameras are seasonal with a noticeable swing between summer slowdowns and late autumn holiday surges. We can draw a monthly chart to visualize 10,000 units scaled by season. Notice how the bars for November and December reach the highest levels, which reflects the gift buying season. The summer months stay closer to the bottom, showing slower demand. We'll keep this chart as our grounding visual. Once we see the bar heights, we can overlay a smooth sine wave to represent how the demand cycles every year. This wave gives us a mathematical handle on the pattern. We'll mark the November peak and the June dip, so the connection between the bars and the wave is clear. We can now write an equation for this wave that matches our observed seasonality. We'll keep the 0 point at January and we'll shift the sign, so the peak falls in November. Let's describe each part of that expression. 10,000 is the base level of sales when we're at a mid-season month. 6,000 is the amplitude, showing how much the sales swing above and below that baseline. The term inside the sign, 2 pi over 12 times parentheses t minus 9 parentheses, shifts the peak to the 9th month after January, which is October-November. Now, let's plug in a specific month and find the predicted pressure. We want to know S of 11, which corresponds to November. Write S of 11 equals 10,000 plus 6,000 times sine of open parenthesis 2 pi over 12 times parentheses 11 minus 9 parentheses. The difference 11 minus 9 is 2, so the inner expression simplifies to sine of 2 pi over 12 times 2, which is sine of pi over 3. Sine of pi over 3 equals square root of 3 over 2, so the expression becomes 10,000 plus 6,000 times square root of 3 over 2. Multiplying 6,000 times square root of 3 over 2 gives about 5,196. Finally, S of 11 approximates 10,000 plus 5,196, which totals 15,196 units for November, near the holiday peak. This is how a simple sine model helps us estimate seasonal spikes. Let's recap. We saw the seasonal bar chart that shows higher demand during the holidays and lower demand mid-year. We modeled that with a sine wave, capturing the repeating behavior, and we wrote an explicit equation with a 10,000 baseline, a 6,000 amplitude, and a slight shift to line up with November. Finally, we plugged in 11 for November and predicted about 15,200 units, demonstrating how the wave gives actionable estimates. Those models help businesses prepare inventory, so shelves are full when shoppers are looking for digital cameras.